Hey guys, as promised, let's try to open this bottle of wine using only our physics textbook and a firm wall. So we'll be hitting the bottle perpendicularly and we'll be creating a force that will be acting against the static friction that is holding the cork down. So essentially what we're trying to do is, instead of pulling it out with a corkscrew, we'll be pushing it out from the inside. Let's get to work.
One eternity later.
Did it work?
Yeah, it worked.
Let's try to figure out what's happened here. We will look at the three main steps. When the bottle is accelerating towards the book, the wine, being heavier than the air inside, has more inertia. It pulls back and collects at the neck. When the bottle comes into contact with the book, it comes to an abrupt stop, but the wine inside is still moving, once again due to inertia. It pushes against the air pocket while also creating a region of very low pressure at the neck of the bottle, forming what we call cavitation bubbles. The air pocket then pushes back against the wine, and as for the wine itself, the sudden change in velocity of the fluid creates a rise in pressure due to the water hammer effect, and in turn, producing a force that acts in the direction of the cork. Now, upon collapsing, the cavitation bubbles produce a force inwards, taking the wine in. And these three forces act against the static friction that is holding the cork in place. So let's talk about the main force acting here, the water hammer effect. It can be expressed by this equation that says the change in pressure is related to its change in velocity, the density of the fluid, and the speed at which the wave travels through the fluid. Now, this phenomenon can be observed in many situations where fluids are involved, such as in fire stations and in your pipes at home. Why did we do the experiment horizontally? This is all to avoid gravity getting too involved. Let's draw the directions in which the forces will be acting. When the bottle is vertical as such, gravity acts along the line of motion. It significantly reduces the water hammer effect in the wine, and it also becomes an additional force that needs to be overcome to remove the cork. If we contrast it with the horizontal movement, the direction of the force due to gravity on the cork and the wine is perpendicular to the intended line of motion, and thus we can produce a greater force on less resistance. Have you ever seen people doing the same thing with a champagne bottle? This is not a good idea, because the champagne bottle is already pressurized, and by slamming the bottle and creating a water hammer effect, the cork is propelled at really high speeds, and this is very dangerous. There are also some safety aspects that we need to consider. So as we mentioned before, the liquid should not be carbonated. If you happen to notice cracks on the bottle, you should stop right away and get a corkscrew as soon as possible. And also, you don't want to do this on drywall. You don't want to break down your house. Alright, that's it for today. Thank you for your attention.